Hello, everybody. I have the top of the hour on my clock, so we are going to get started. I want to thank everybody for taking the time to join me today. I hope you are all having a good day so far. So we are going to talk today about using the GeoWeb GeoCell solution for dams, dikes, levees, spillways, and other scenarios where you are having to protect against water flow. So my name is Sam Justice. I'm your host today. I've been with Presto for nearly 10 years now after coming from the consulting world. I'm a licensed professional engineer in several states with degrees in both civil and geotechnical engineering and work with ASTM and ISO in the geosynthetics industry. I am one of the engineers here at Presto Geosystems, and we manufacture erosion control, stormwater management, and porous pavement products, all made in the upper Midwest of the United States. Through an extensive national and international distribution network, we offer both technical and on-site support, as well as free project evaluations from our in-house engineering team, such as myself. So today we are going to cover a couple key points, benefits, including how the GeoWeb system can have erosion protection, including how it can protect against material washout due to water flow in a variety of different project conditions, how the GeoCell technology can accommodate typical construction issues and design challenges, and then finally, how the GeoWeb system can potentially reduce the vertical pressure on your subgrade to allow for reduced cross-section thicknesses whilst not compromising the structural integrity of your project. So if you do have any questions today, please put them in the questions tab on your GoToWebinar menu, and I will answer those hopefully during the presentation, but if not, we will have a Q&A session at the end. So a little bit about Presto Geosystems. If this is your first time with us, Presto Geosystems collaborated with the U.S. Army Corps of Engineers to develop the GeoCell technology in the late 1970s, and we have remained at the forefront of innovation in this market ever since. We offer more than just a product. We partner with our customers from the initial concept phase through construction to ensure project success. Our worldwide distribution network is highly experienced not only in the GeoCell technology, but other geosynthetics as well. And I firmly believe that we have the most knowledgeable distribution network that is available on the market. And our project assistance continues even after the product leaves our facility. We're not just selling you something and leaving you hanging. So we do operate in 4 main application areas when using the GeoWeb GeoCell. Those are going to be load support, where you're supporting vehicles, slope and channel erosion protection, and then constructing green retaining walls. We also offer porous pavement solutions, which we have both a vegetated and a aggregate surface solution, and lightweight reusable construction mats, something that would replace your timber matting. We're not really going to talk about either one of those options today, the porous pavements or the construction mats. We are going to be focusing on the GeoWeb GeoCells and how they can be applied to retaining walls and reinforced slopes. But if you do have any questions about our other offerings, feel free to reach out to myself or the rest of the Presto engineering team, and we'd be more than happy to talk about those as well. So let's talk about some general information about GeoWeb GeoCells and what a GeoCell is, how it's used, that sort of thing. So the GeoWeb system is our version of the GeoCell technology, and it has 2 main characteristics. The first one being the cell or the container size. And so the cells do come in 3 diameters, a small, medium, and large size, and then cell wall heights available at 3, 4, 6, 8, and 12 inches. And the actual cell size and cell height that you are going to choose for your project do depend on your site-specific details and site conditions. So there's no one right size fits all. There is a specific one that is going to be the most applicable to your specific site. Presto Geosystems does offer a free project evaluation service, including written summary, calculations, cross-sections, and specifications, regardless of project size. So even if it is something very small, feel free to reach out to us, and we're more than happy to help you determine which one is going to be the most appropriate. Don't think that just because you have a small project, it's not something that we would be able to help with. And so, like I said, this evaluation does help determine that appropriate size and depth of the cell to help ensure your project success. And one of the things is that we don't follow tables or graphs, something that gives general idea of what you might use. We do use project specific data because each project is unique, and it is important to us that we get you the size and system that is going to be the most appropriate to make sure that the solution works for you. Something else I want to point out about the GeoCell is going to be the ultrasonically welded seam, and that's going to be where each of the points are that connect the cell walls. And that's crucial to the functionality of a GeoCell. The stronger your seam strength, the better the GeoCell's performance. The GeoWeb's GeoCells is made with 100% virgin high-density polyethylene, HDPE, providing the strongest wall strength while still maintaining semi-rigid ductile properties throughout the cell walls. So if your cell wall is too stiff, it can overstress the seams and potentially cause seam rupture, which would lead to failure, something we are all obviously hoping to avoid. The second attribute, I mentioned there were two. So the second attribute of the GeoWeb system is going to be the infill material that you choose. So there are three main infill types that you can use with the GeoWeb system, depending on the type of protection that is needed. You can use topsoil, get vegetation growth, aggregate or granular soils, and then concrete. In most cases, this will allow for the use of on-site materials without the need to import fill. So if you've done any excavating on site, or if you have a close nearby material source that you want to use rather than importing, engineered material, that is going to be perfectly acceptable. So in general, the GeoWeb systems are typically going to use either topsoil for that vegetated face or aggregate if you don't want that vegetation. Concrete is less common. It's typically used in more extreme environments where maybe you're going to have heavy wave action, something like that. Definitely can be used, just a little less common. And this is just a quick one-page summary of the GeoWeb specification. I do want to just sort of give this to you as something to highlight so that you know the type of information that you would want to look for if you do start looking into GeoCells. So the GeoWeb system is manufactured from a proprietary blend of a high-quality virgin high-density polyethylene, and it has proven its durability for more than 40 years. This is a well-proven system that does not have any, polymers, exotic alloys, doesn't use recycled materials, calcium carbonate, anything like that. It is just that HDPE. So the GeoWeb system is designed to last over 100 years, with lab testing showing that it can withstand up to 150 years before you have carbon black degradation. And so that's with even continuous 24-hour 365 sun exposure. So we do stand behind our data, ensuring that you can confidently build with materials that you can trust. So we've been doing this since, like I said, the 1970s, haven't reached that 150-year mark, but we are well on our way, and we are very confident in the materials that we produce and get put in the ground. So the GeoWeb system and our accessories are all 100% made in the USA under strict quality assurance and environmental control processes, sure to comply with all requirements for the Build America, Buy America and the Infrastructure Investments and Jobs Act. So especially if you are looking for grants or potentially using federal dollars, maybe you're with a Department of Transportation project, something like that, and you have those requirements for made in the USA, that sort of thing. The GeoWeb system and everything that we offer does meet those requirements. We don't import from overseas. We are not a Chinese brand, anything like that. So it is always great to invest in America and build in America. So, and one of the reasons that Presto Geosystems is the world's most complete multi-component geocell cellular confinement system is that we back all of our testing and all of our innovations with accredited research, and have done so since the creation of the geocell technology in the late 1970s. And these are from industry-leading geocell researchers in the US and beyond. These are the guys that are 100% trusted in the industry, and they have done significant amount of testing for us, and we've done it all over the world. We have projects all over the world to show that this is something that is a good and proven technology that's going to function the way that we say it does, that you expect it to, all of those sorts of things. And we do work very closely throughout the geosynthetics industry. Like I said, ASTM and ISO are very popular ones that everybody sort of knows, but we also work with the International Geosynthetics Society. We work with AREMA when it comes to railway projects, AASHTO, and many Department of Transportations when it comes to building roadways, that sort of thing. So this is definitely a regarded product in the geosynthetics industry. It is not, something we're trying to put out there that doesn't have any backing behind it. So if you do have any questions about that, or if you need any of the qualifications, we can offer those as well. All right, so with all of that, one of the things I've mentioned a couple times is that the GeoCell system has some accessories, some components that are basically the supporting pieces that make the GeoWeb system the most complete GeoCell system. And they also ensure the uniform performance of your interconnected system, thereby protecting against the damaging effects of non-uniform deformation or differential settlement in response to your applied loads. So we do have a couple different accessories, pretty wide range really, that are designed specifically for various applications of the GeoWeb system. And so these accessories are engineered to enhance both the long-term structural integrity and the efficiency of installation. So the calculations that we offer in our project evaluations are based exclusively on Presto's proprietary accessories, and they're not applicable to other geocell manufacturers. And part of that is because we don't endorse the use of those generic tables or graphs. I mentioned that before. Each project is evaluated specifically and individually, considering your on-site specific conditions and the use of our proprietary accessories. These are all the things that are going to help get you that solution that is right for you. And if you start trying to go and use some of the cheap Chinese knockoffs that exist for everything nowadays, you're not going to get the type of performance that maybe you were hoping for. So to cover a couple of these, the first one is going to be the ATRA key, and this is our crucial component for that fully integrated system. The ATRA keys connect each individual GeoWeb panel into a single web that covers your entire project area and significantly speeds up your installation. Made again from that durable HDPE plastic, they will last the lifetime of the project without breaking down. ATRA keys ensure that the panel remains securely connected and that the GeoWeb system does not fail under your anticipated loads. And their specific engineering values guarantee that the system's durability over time, avoiding the corrosion that you would see with something like metal staples or failure of underperforming zip tie systems that don't always have the structural integrity that you were hoping for. And so this is what that ATRA key is looking like. You can see how it can be used to connect all of the individual panels together to cover your entire area. I just want to sort of give a close-up of what that ATRA key does look like. It is a single connected piece, and you will notice that it has we call them frictional barbs, and that's designed to enhance the interlock with the GeoWeb textured cell wall. And so these barbs are a recent improvement to the ATRA key, and collectively all of the features of the key provided added protection against the three primary modes of mechanical junction failure, including shearing, splitting, and peeling. Additionally, we have evaluated the factor of safety for the ATRA key connection in our project evaluations. And so I'm going to keep saying it. It is crucial that your manufacturer, if you decide to go with a GeoCell, whether it's us or anyone else, it's crucial that that manufacturer provides calculations to verify those factors of safety for each of those primary modes of panel connection failure, and is based on their specific panel connection method. We offer ours using the ATRA key. No one else has the ATRA key, so their calculations should follow what their connection method is. So that's just something to keep an eye on as you are evaluating which GeoCell you might want to use. So we also have anchorage options. So if it is a perfectly flat system or a relatively low grade where you're placing the GeoWeb panels, you don't need to have any anchorage. Gravity is going to do the work for you. However, a lot of times you are placing the GeoWeb system on a slope, and so you are going to need to anchor that GeoWeb panel in place so that it doesn't just slide down your slope face. If you have a relatively shallow slope, think a 2 horizontal to 1 vertical or shallower, so like 26 degrees or less, you can use the stake anchorage option. That's usually going to be sufficient to hold the panels in place. We do offer 2 options for stakes, one being using standard metal rebar, and then we have a small clip that goes on the top of that rebar to help hold it to the panel. Or we offer what we call our Atra Speed stakes, which are again fully HDPE made material, so it doesn't have any metal, doesn't have anything like that. So it is great if you are perhaps in a saline environment, you wouldn't want metal to corrode, or if you are going to be in an electrical area, maybe you're working in a electrical substation and you have to worry about touch steps, so you don't want to have any additional metal put in the ground because that is an electrical hazard. The Atra Speed stakes with the GeoWeb system make sure that your system is completely plastic. You don't have any of that touch step potential, so it's an added benefit for safety as well. So stake anchorage is your first option, but if you do have steeper slopes, you can go with what we call our tendon option. This is also good if you are trying to protect something like a geomembrane liner, something that you don't want to puncture with stakes, because that sort of defeats the purpose of a geomembrane liner. You can lay the GeoWeb panels on top of that or on top of your slope, and then run tendons through and have them tied off to crest anchorage. So the tendons would be those white strips that you see going through the right-hand photo there. And then we have our Atra tendon clip, which is our load transfer device. So it is the thing that connects the GeoWeb panels to the tendons and then all the way up to the crest anchorage system at the top. And so this allows for a lot of pre-assembly as well, so you're not doing slope side work, which is great if you are on those steeper slopes. Maybe you're on a 1-to-1, a 45-degree slope, makes it really difficult to put manpower on that slope face to do the work. You can do all of that before you deploy the GeoWeb panels down the slope face. Okay, so let's look at some applications. We've now learned what the GeoCell system is, how it works, what our accessories are. Let's get into what we're focusing on today, our application-specific uses. And we're going to start with the armoring of your dams, dikes, levees, those sorts of applications. So I'm sure most of you, if you are in this industry, can see a typical detail like this. You have the wet side and you have a dry side. The GeoWeb system can armor both sides. So if you are on the wet side, you would typically put in either an aggregate fill or maybe concrete if you know you're going to have wave action, if you're on a coastline, or if you have a really long lake that has a lot of wind potential to generate those waves. Maybe you do need that concrete for extra protection. So you can have that on the wet side. You can put the GeoWeb system up over the crest and even potentially drive on that. We're going to talk about that in a little bit, but you can have that be an access road along your dam or your dike, that sort of thing. It can either be concrete or aggregate, depending on what you've used on your wet side. And then on the dry side, you can fill it in either again with aggregate if you're going for that look all the way across, but more likely you'd actually fill it in with topsoil and allow vegetation growth on that dry side. That way you have vegetation, looks a little nicer, a little more environmentally friendly, but you would still have that erosion protection should overtopping occur. Now, I mentioned you can drive on the top of the GeoWeb system over the crest of your dam or your levee. And so this would be what we consider our load support application. So I just want to cover that in a little more detail. So with the GeoWeb system, you are confining the material, and it's that confinement that is making it a drivable surface. So it operates by distributing vertical cyclical load. So as you're driving across it, you have that cyclical load rather than a single applied dead load. So when that vertical load is applied, the active earth pressures within the loaded cell pushes back against the passive pressures in the adjacent cells, thereby supporting the load collectively, all of those cells together. Each cell aids all of the surrounding cells. And so, as we mentioned, you can fill in the GeoWeb panel with any sort of aggregate or granular material. So you can even do sand, you can do recycled materials, you can do low quality, low friction angle materials, because the GeoWeb panels quickly redirect that vertical load horizontally to engage those cell walls and generate hoop stress in those loaded cells. That hoop stress is what's going to carry the load. And so the ability to disperse that load distribution is crucial for maintaining system integrity, creating what we call the mattress effect, or maybe the snowshoe effect, if you're familiar with how snowshoes can distribute your load so you can walk on top of a snowbank rather than sinking down into it. So the strength of your internal seams, that ultrasonically welded point that I'd mentioned, your panel connection method, which in our case is the ATRA key, and the increased load bearing capacity through that mattress effect generated by the hoop stress in the cell walls are all key factors in enhancing a GeoCell system's performance. The GeoWeb system confinement prevents that lateral shifting of your infill material, thereby eliminating the rutting and controlling differential settlement through the drive lanes. So I know that was all a lot, and definitely feel free to throw some questions at me if I didn't quite cover everything, but the sort of key point comes out to what you see in this graph here, and that is how the stresses are distributed when you have GeoWeb reinforcement. And basically you have, in this case, on the left-hand side, an unsupported subgrade and the GeoWeb reinforcement on the right. And the unreinforced section shows your typical stress distribution curve with your highest stresses at that interface between the tire and the road. And that load is dissipated over a typical unreinforced 45-degree load distribution angle, makes that stress bulb under there. Anybody who works in roadway design would be familiar with this. It is not anything new, unfortunately. But with the GeoWeb reinforced section, it is new because we are able to eliminate the highest levels of stress, that orange and red section of the stress ball. And we're able to spread it over a much wider area. You don't have that 45-degree angle, you have something significantly shallower. And that is that mattress effect that we talked about. So by spreading that load over a wider distribution angle, the stresses reaching the subgrade are significantly reduced, controlling deflection, rutting, differential settlement, all of the key things that can destroy a roadway surface. And a general rule of thumb with the GeoWeb system is that you can reduce the stress reaching your subgrade by about 50%, which is significant. And a project evaluation based on your site-specific conditions can show the actual stress reduction. So if you are maybe driving over a culvert, or if you've got utility pipes, anything underneath the roadway, and you know that you have a maximum allowable stress on top of those, we can make sure we design a system that is going to meet that required stress. And we can show that in our calculations so that you have proof and say, this is something that is going to reduce that stress and get us to where we need to go. All right, a couple benefits of using the GeoWeb system in those sort of unpaved roadway scenarios include reducing your cross section by a significant amount. Like I said, up to 50% is pretty common, which is a pretty huge reduction in that cross section thickness, while still supporting the same vehicle loads. And the GeoWeb panels help prevent rutting and uneven settlement of the aggregate by controlling and stabilizing the movement of that aggregate when it's being driven on. So that aggregate is held in place by the individual cells of the GeoWeb panel, so they're not getting pushed down or to the side under tire loads. And the stress reduction and the stress spread that we just saw, that keeps the roadway in place a lot longer without repetitive maintenance. So less maintenance overall, you're not coming back and constantly fixing that roadway surface. It's great for those access roads over your dams and your levees so that you don't have to worry about vehicle stresses causing damage. All right, and roadways and drive access is great. It's a huge benefit of the GeoWeb system, but the main focus for the GeoWeb system when it comes to dams and other hydraulic structures is the erosion control benefits on the slopes, both the wet slope and the dry slope. And so that's what we're going to start talking about now. So the GeoWeb system is an economical alternative to large riprap stones or reinforced concrete on your dam faces and your spillways, and can allow for those vegetated faces that might not otherwise be possible due to the hydraulic forces at play. So when rock is used, the GeoWeb system allows you to greatly reduce the rock size. And if you do use concrete, we can cut that required concrete thickness pretty much in half when compared to reinforced concrete solutions. So it's a great way to, again, either have that reduced thickness, maybe get easier to access stone. You don't need large 14 to 18-inch riprap stone. You can use 2-inch crushed aggregate. You know, it's easier to have. Maybe it's something that you have on site that you can get. So a lot of good benefits there. So this is a pretty typical slope section, and I just want to sort of highlight what it might look like. So you would have your slope face. You might need a planar geosynthetic underlayer, and basically that means maybe you have a geomembrane liner, and that is totally up to you. That's not something that we say you have to have. You absolutely are not required to have a liner. Sometimes levees or dam faces require that. If you do, totally good. We can work with that. If you don't have a liner, good. We'll just lay it directly on the slope face. You could also sometimes have geotextiles, either a woven or a non-woven. Again, this is depending on your site-specific conditions. They are not requirements. They are an optional thing based on your specific project needs. And so if it is necessary, we can work with that. It is very easy. It's something that we do every day. If it's not necessary, then you just lay the GeoWeb panel directly on the slope face and good to go. You have your different anchoring options. We talked about those. You can either do the stake anchors, and those are along the slope face, or you have your tendon option, where then you have crest anchorage, typically a buried dead man pipe, but we also frequently see earth or rock anchors, or even tying off to existing structures. If you've got a building, per se, at the edge of that crest, you can tie off the tendons to that building and use that to hold the GeoWeb panels in place. You typically will not see both anchorage options together. It is either stakes or tendons. Very rarely do you see both together. So just something to keep in mind. And then you fill that in with your info material. Again, you can do topsoil, you can do aggregates, or you can do concrete. And then if it is topsoil, you let that vegetation grow. Easy enough. All right. So couple structural and stability benefits to using the GeoWeb system. And the biggest one is that it does hold all of that material in place. It is not allowing it to be, saturated and move as a large mass, because it's confined into each individual cell. So you are going to help reduce superficial erosion due to either water movement, saturation of the slope from either rainfall or from just a saturated soil coming up from the groundwater system. And it also helps protect against wind erosions. If you're on a coastline, that's something we see that you might have issues with if you're in a particularly windy environment. So it does help prevent things like rills and gullies from forming. It's going to help prevent that superficial sloughing, that sort of thing. And it does somewhat benefit the undermining, somewhat benefit in limiting undermining of the layers below the GeoWeb panel, but this is considered a superficial system only. It does not support global stability of the slope. So the slope does need to be stable on its own prior to the installation of the GeoWeb system. Just something to keep in mind. And like I said, you can do a variety of infills with that. And one of the great things about it is that you can typically get vegetation to grow at a steeper angle than it normally would be. Same for stone. You can get that up to a 45, even a 50 or a 55 degree slope angle that it might not otherwise be stable at on its own. And then obviously concrete, you can get that. It's a little easier to install those steeper slope angles with concrete when it's confined within the GeoWeb system. And like I said, this is how that confinement works. By preventing the material from getting picked up and washed away due to water flow, you are preventing those things from things like rills and gullies from forming, so that it can have that superficial protection without large mass movement. And it does help hold that soil in place allowing for that vegetation to grow. So like I said, hard armoring versus soft armoring. Soft armoring is that topsoil with vegetation. Hard armoring is either going to be stone or concrete. This is in areas where maybe vegetation isn't going to grow. If you're in a desert environment, perhaps, or if you just don't want to deal with vegetation, you can put in stone, and then concrete for those more extreme environments. Wave action, very high flow situations. Maybe you're diverting large amounts of stormwater runoff and you have a diversion channel. Potentially you would want concrete there so that you don't have to worry about any erosion, because that concrete is going to be able to withstand whatever you need. All right, so I did mention way back at the beginning, we do quite a bit of testing and research with the GeoWeb system because we want to be confident ourselves and be able to give you confidence that the GeoWeb system is going to perform the way that we say it does. And so one of the main testings that we did recently was at Colorado State University. This was some hydraulic testing. This was under the direction of Dr. Chris Thornton. CSU is considered one of the top hydraulic research facilities in the world, so we are very lucky to be able to work with them. And the facility is actually pretty unique. I don't know if anybody has had the chance to get out there, but if you are interested in hydraulic research at all, you definitely should try. It is located underneath the Horseshoe Reservoir and is a couple hundred feet of static head. And so it can actually achieve some of the highest velocities and shear stresses in their testing flumes anywhere in the United States. So very cool facility, very happy that we were able to get around to work with them. So we did a number of tests with them for all of our different infill types, vegetation, aggregate, and concrete. So we'll start with the vegetated infill. And so this was a test that we did with the 6-inch deep GeoWeb system filled with that topsoil. And then in this case, it was covered with a mid-grade turf reinforcement mat and had the vegetation allowed to grow. So vegetated infill testing was performed with two objectives in mind. The first was the ability to withstand those high velocities and shear stresses, which are the main components you're going to think about when it comes to withstanding water flow. And then the second objective was that we wanted to compare the performance of topsoil filled GeoWeb versus riprap or things like erosion control blankets by themselves. So we wanted to be able to compare how the GeoWeb system performed with other types of traditional solutions. And so here you can see we said our peak velocity was about 30 feet per second. Peak shear stress was 16 PSF, which is pretty remarkable, I would say. There was 0 topsoil loss in the first ½ inch, which is great. It means you're not losing the soil and just exposing the roots of the grass. Everything is staying in place where it's supposed to be. All sorts of good things. And so here is that comparison to a number of different traditional solutions you might think of, including bare soil all the way on the left side of the graph. 12-inch riprap stones are sort of right there in the middle. High performance turf reinforcement mat by itself is the next one. And then the GeoWeb with that turf reinforcement mat is on the far right-hand side with the allowable shear stress and allowable velocities there. You can see significantly higher than any of your traditional solutions. So really great results. You can see that they sort of speak for themselves in this case. The GeoWeb panels confine all of that soil so it doesn't get saturated and just wash downstream. And that's typically how blankets fail when they're by themselves, is that the soil underneath the blanket becomes saturated and starts to move. So even though an erosion control blanket or a turf reinforcement mat might protect the surface from water flow, once the soil underneath it gets saturated, you still have the potential for washout failure. Not going to happen with the GeoWeb system. All right, we did, like I said, testing with aggregate infill. And so this idea was to determine what rock size can you use in the GeoWeb panels to achieve the velocity, to achieve the withstanding velocity that you need to. And so the idea is you want to reduce it from your large riprap boulders down to a crushed aggregate that is going to be much more accessible. And so the idea is to say, what is the allowable velocity that will not wash out a single stone rather than washing out the whole thing together? And so we did compare this with the ABTS and U.S. Army Corps of Engineers riprap systems, and we're able to see typically a 2 to 10 times reduction in rock size. And typically we recommend between a 3/4 inch and a 2-inch crushed aggregate. And so that's going to be your typical size. It is going to depend a little bit on what size GeoWeb cell you use, and it is going to depend on your velocity. So those are sort of things that we can help you determine. We do have our calculations that help us determine which one is going to be the most appropriate based on those project conditions. But yeah, 3/4 inch to 2-inch is going to be the most common sizes of crushed aggregate that we would recommend in that system. So something to keep in mind, there is no one right answer. Again, everything about this is that it is unique to each individual project, but that's sort of the range that you're going to be looking in. And then you can have concrete as the info material. We have testing to show that it withstood velocities of 36 feet per second. The only reason we have that number is because that maxed out the flume at Colorado State University. Their flume actually overtopped. We were just spilling water over the top of the flume, couldn't get the water to flow any faster. So basically we take this as confirmation that when concrete is used, even under the most extreme flow conditions, this GeoWeb system is going to be something that holds everything in place. You're not going to have to worry about degradation, anything like that. And one of the great things about the GeoWeb system is that it acts as the formwork for the concrete. So you're not having to build additional forms on your slope faces and pouring into those. You're pouring directly into the GeoWeb panels, filling each one of those cells and allowing the concrete to set. So it's really a great way to help speed up that installation, all of those good things. By doing the confinement within the cells, you are able to use a slightly higher slump concrete because you don't have to worry about it settling into the bottom of your form because it's confined into each individual cell. Typically, we do recommend somewhere between 3,000 and 4,000 PSI concrete be used. But again, that is something that we can work with on a project-specific condition if you had a different mix that you were hoping to use for your project. And typically we do see 3-inch deep concrete-filled GeoWeb panels replacing 6 to 8-inch deep reinforced concrete without the GeoWeb. So again, you have that 50% or more reduction in cross-section depth, which is great. And so, like I said, you pour directly into the GeoWeb cells and then you screed that concrete flush with the top of the cells so that you know you have a consistent and uniform concrete thickness over your entire project area. And again, you can have that higher slump to make installation a little bit easier without worrying about it all slumping to the toe. And then you can have a broom finish if that's what you're looking for, or a smooth finish, whatever you need depending on your project details. And you can see that it is still a pretty flexible system, even with concrete. So you do have a little bit of what we call our own construction joints. So along the cell walls, the concrete does break apart slightly so that it does have that flexibility. And so you don't need to have any construction joints on your own. And something that is always important with concrete structures is drainage. You do need to still include some sort of drainage behind GeoWeb when it's filled with concrete. Things like weep holes, you can either just drill them through set concrete, or if you want to install like weep drainage tubes, those work. Or if you have wicking fabric behind the system, drainage tubes behind the system, something like that. Just definitely something to keep in mind. You don't want to have pore pressure build up behind those walls. But yeah, you're typically going to have that 3-inch deep concrete and you are screeding it to the top of the cells. You're not overfilling it. You don't want to have additional concrete on top of the cells because it will because those cell walls do create those mechanical breaks, it would break up through any of the overfill and it would just become loose, broken concrete that would slough away on its own. So that's why we do say screed to the top of your cell wall. So however deep your cell is, 3, 4, 6 inches is how deep your concrete's going to be. And this was just a quick summary of the testing that we did. And like I said, we maxed out the flume at 36 feet per second. We were the only geosynthetic to ever do that at CSU. Articulated concrete blocks didn't max out the flume. Gabion baskets didn't, anything like that. So only concrete filled GeoWeb has ever maxed out their flumes. That's a little point for us. But so it really shows the strength and stability of this type of application. All right, let's do some case studies. Everybody likes to see how these sort of things work in the real world. Nobody likes to be the guinea pig. It's always nice when it's already in the ground somewhere. So the first one that we're going to look at is at Mud Lake Dam. It's in Nevada. This was a 100-year-old earthen dam that no longer met safety standards and needed to be rehabbed. Pretty standard, at least in the US, to see these types of structures. And so a cost-effective alternative to a traditionally reinforced concrete solution was what the owner was looking for. In this case, the selected solution involved a 16-ounce non-woven geotextile, and then a polypropylene geomembrane, and then another non-woven geotextile, so it's sort of a sandwich. This was determined by the dam owner. This was something that they needed to meet their hydraulic requirements, and so it was something that we had to work with that was already going to be on site. This is not a typical thing to see these sort of sandwiches like that. That is a pretty heavily reinforced geomembrane liner. But like I said, it is definitely something we can work with. If it's something that you need for your project, then we're going to work with you. We're not going to dictate that sort of thing saying yes or no. So they put that down, and then they wanted to do a concrete filled GeoWeb on top of it. So they put the GeoWeb panels over top of that geotextile geomembrane sandwich, and because it did have that geomembrane, they didn't want to use stake anchors because they didn't want to drive stakes through that membrane, sort of defeat the purpose. So they did that tendon system and tied it off to a buried dead man pipe at the crest. You can see they started digging the dead man pipe, or dead man trench. In the left photo on the far left side, you can see the trench being dug there, and they terminated the geotextile geomembrane sandwich in that trench as well. So they were able to just sort of double up on that trench without having to dig two of them. So the geomembrane provides that nice impermeable waterproof barrier that's great for earthen structures. If you have one, totally good. We can work with it. If you don't have one, no big deal. So here you can see them doing that pre-slope installation. So I mentioned this way back when in the beginning, by being able to run the tendons through the panel, tie them off to the Atra tendon clip, our load transfer device, and tie them to your dead man pipe before you get on the slope. This is a great way to get a lot of the slope side work off the slope. So you're saving time, saving money. It's a lot safer. You're not putting guys on harnesses and dragging them over steep slopes, not walking on slippery geomembranes that you might puncture accidentally with a boot, all that sort of stuff. So you can do all of this sort of pre-installation work on nice flat ground and then just pick it up and drape it over that side, over that slope when you get there. So in this case, like I said, they did choose the 3-inch deep GeoWeb cell, and so they were able to pour the concrete directly into that. Again, you screed it flush with the top, so it is 3 inches deep all the way down the slope. And then you do typically want to pump that from the top to the toe. And that is just ease of installation thing, help keep pushing the concrete down so that it reaches in and fills every cell. In this case, it was only a 2 horizontal to 1 slope, so that's why the guys were on that slope face. They didn't seem to have any harnesses. Leave that up to your own OSHA regulations as to whether or not that's acceptable to you or not, but you can see that going in here. And one of the great things about the GeoWeb system acting as its own formwork is that you don't have to pour the entire concrete mass at the same time. You can pour it in smaller sections over the course of days, weeks if necessary, however long it takes, without having to worry about different setting times between all of the different concrete, because the concrete is confined within those cells, and that's where it's going to stay. It's its own little bit of concrete. It doesn't need to be connected to the whole mass. And in this case, the GeoWeb alternative cost was about $10 a square foot installed. So they were able to save over $500,000 on this 90,000 square foot project. So about a 40% savings rate compared to a traditionally concrete reinforced slope solution. So a great way to save a lot of money in this case. They were able to do a lot more work pre-slope, able to do the concrete installation over a longer period of time. You can see it's quite remote. So they were able to have a little more flexibility in their installation times, which is always a great thing. All right, so this is another case study. This is now in Oklahoma, the Lake Hefner Dam. And so this is a vegetated solution on the dry side of a dam. So the Lake Hefner Dam was experiencing erosion damage along the bank and underneath the road on the dry side of this dam from a number of years from overtopping from the dam, but also sheet flow off of this paved road. So the water was flowing off of the road down the dry side of this dam, causing erosion. It was undermining the road. You can see that road was starting to become damaged. And so in this case, excessive rains and high winds had contributed to the overtopping issues. And so they decided not to put the GeoWeb on the wet side because they were very concerned about the wave action and all of that. And so they went with their traditional solution of very large riprap stones. Totally acceptable. We understand it. Sometimes when you're dealing with regulatory bodies, they want the tried and true method. And if you need a solution fast, you don't necessarily have the time to walk through some new solutions with everybody. So they replaced all of the riprap on the wet side and then needed to work on the dry side. So like I said, put in new riprap. They also put in a stone wall at the top to raise the height, again, to try and prevent further overtopping. And then they put in the GeoWeb slope protection system on the opposite embankment to prevent that future soil erosion and sloughing, and also to try and help reinforce the road and prevent undermining. So it was placed on a 2 horizontal to 1 vertical, and they were anchored with the Atras speed stakes. Those were those HDPE stakes. So they were able to avoid adding any metal to this system because they didn't want to have to worry about corrosion of the metal over time. And so the stakes were able to hold the panels directly in place and put all the way up against that roadway face so that there wouldn't be any areas of undermining. And so here you can see once it's fully vegetated, one of the great things is you're not going to see any of the plastic. You're not seeing this big plastic along your slope face. It does just look like a beautiful green slope. No one is going to know that it's reinforced. No one's going to know anything is there. The panels aren't going to work themselves back up to the surface for any reason. And so this is one of the things that is now going to last the lifetime of the project. Typically with dam structures, you see them being a little longer than normal projects, 100 years maybe. The GeoWeb system, like I said, has that 150-year lab testing showing that it is not going to be degrading. It's not going to fall apart. It's not going to become brittle. You're not releasing microplastics, anything like that. So yeah, you do have that 100+ year lifetime with this, where it's just going to be buried in the ground, allow that vegetation to grow and look nice. And now you don't have to worry about erosion on this slope face and erosion undermining that road. So great things. All right, one last case study. So this is an impoundment pond. This was down in Florida. And so they were looking for a solution to be able to drive over the crest and the bottom of this pond for maintenance activities. So in this case, they chose concretes and they wanted it to cover both the slopes and the crest of the dam so that, again, it could have that drivable surface. And when the water was drained out of this pond, they could drive down the slopes and drive on the bottom of the pond for any maintenance and clean out activities that they needed to do. So spillways are also pretty common applications for the GeoWeb system. So let's look at some of those. So spillways are where you're just covering a pretty small area typically, where you know you're going to have that higher water flow because you're collecting and directing water. And so again, this can be on dam faces, or it can be in smaller application environments. This was down in Florida again. This was a 4-inch deep concrete geoweb that was utilized at a medical complex. So they wanted to collect the water and send it down this flume and down a spillway apron into a holding pond that was designed to capture that runoff from this whole big medical facility. So they knew that they were going to have very intermittent, but potentially very high flows during those storm events where they were collecting water from this large site and directing it into this holding pond. And so they were able to lay the geoweb down over the spillway apron, again, fill it in with concrete, and now you know that it can handle, like we said, testing showed 36 feet per second, but experience has shown significantly higher flows than that. And so they were able to cover all of the area that they needed on that spillway apron and some of the side slopes to show that this is now going to be safe from erosion while that water is directed into the pond. Another one, this was in Pennsylvania. This was at a country club. So this was another hard armor solution. This is again used with concrete, and it doesn't need any forms because you're able to just use that geoweb panel as the formwork. And so it was a pretty small area, but they were able to, in this case, put a geotextile down because they didn't want to lose any of the concrete underneath the system into sort of the wet, saturated ground underneath it. So a geotextile was placed to sort of help be a bottom border for that concrete. In this case, they also put some additional borders along the edges, and that was because they wanted to have a sort of more defined border between where the concrete would be and how the vegetation was going to grow up. Gives you that sort of nice straight line along your edges. Again, that's a project specific thing. That's if you need it, if your client requires it, regulations, that sort of thing. And then this is what that looks like. Again, just dropping that water through the spillway into a holding pond. But it's really nice because you can have significantly reduced concrete depth when using the GeoWeb system. Also allows you to go around corners, curves, dips, hills, that sort of thing, contours to the landscape a lot better. So in this case, it's a chunk of concrete in the middle of your golf club, but it does look as natural as you're going to make concrete look. So it's a little nicer aesthetically and is a more economical solution than reinforced concrete. All right, so that is my presentation for today. So basically, in summary, the GeoWeb slope protection and load support systems can help your structures for erosion control due to water flow, extreme events, and vehicle loading. It can reduce your lifetime maintenance and repairs. And it has a variety of infill materials that you can use in different installation applications to make the GeoWeb system a good fit for most project conditions and to help solve or mitigate some typical construction issues with this type of application. Additionally, confining the material and reducing that stress can potentially decrease the overall thickness of your cross section while still giving the structural integrity that is necessary. So we do offer a comprehensive system solution for dams, spillways, levees, and other hydraulic infrastructure, and our recommendations are tailored to project-specific information, details, and site conditions. All right, like I've mentioned a couple times, we do offer those project evaluations. They are a free service, and they are regardless of project size. So don't think just because you've got a small little spillway, like we saw some of those projects, that we're not going to be able to help. It does not need to be 100,000 square feet to interest us. But you can go on our website. It's the free project evaluation. You fill it out with as much information as you can. You can attach relevant documents such as geotechnical reports, if you've got plan drawings, anything like that. And we are going to get you that information. We do have our complete project evaluation, and that is going to include those written summaries. It's going to include CAD details, supporting documentations, all of our specifications, everything that you need to put into your bid documents or to share with any interested parties or regulators so that everybody is comfortable and on board with using one of these systems. And so we do deliver quality and have over 40 years of expertise, guaranteeing each shipment meets or exceeds our specifications so that you can deliver certainty and build with materials that you can trust. No disclaimers, no fine print, nothing that says, hey, we're just going to sell this to you and disappear. We are going to help you every step of the way. Little bit of housekeeping before we get to the Q&A session. PDH credits, if you have managed to listen to me this whole time, you have earned yourself a PDH credit. So if you are listening live, today is June 6th, June 10th, excuse me. So if you're listening today, June 10th, you will receive an email from GoToWebinar, and that's going to have a link to download your PDH certificate. And then a couple days later, you're going to get an email from Presto Geosystems with a link to your webinar dashboard. And so your dashboard is where we keep our library of all of the webinars that we have presented, and where you can watch any of those webinars and get more PDH credits. So if you missed a live webinar, you can get on your dashboard and rewatch that webinar and still get your PDH credit, and that's where you would get those, is from your dashboard. So 2 emails, one from GoToWebinar, usually by the end of the day, and one from Presto Geosystems, usually by the end of the week. So look for those, check your spam folders, firewalls, all of those good things that we all deal with these days. But if you do have any questions, feel free to reach out. We are happy to assist you if there are issues. And thank you so much for taking time out of your day to join me. My contact info is here. Please feel free to reach out to me at any time. Even if you are curious about the GeoWeb system and you don't think, well, I don't have enough information for a full project evaluation at this time, I just sort of want to talk, see, 10,000 foot level, what are we looking at? Feel free to reach out to me. I'm more than happy to discuss that. Make sure that what we are offering is going to be the right solution for you. The GeoWeb is, I think, a pretty cool and unique system, but it is maybe not always going to be the right solution for every single project. And we want to make sure that what we're giving you is appropriate for your specific challenge. So definitely feel free to reach out. Always happy to discuss. If you've got a couple more minutes, I'm going to go through a couple of these Q&As. There's quite a bit of them. I will also reach out to you directly if I don't get to your question. So definitely feel free to reach out. One of the big things is if you are looking for a distributor, if you already know what you want, you just want to talk about pricing or material availability, on our website is another form that says Find My Distributor. So definitely go there. You just sort of put in your project location and say, hey, I'm looking for somebody to talk about pricing or material availability, and we'll get you connected with them right away as well. So that's a good step to not have to go through me directly to connect you with a distributor. You can just go straight there. All right, some questions. So basically, do you want to ever overfill the concrete on the GeoWeb system? Do you want it to be taller than the GeoWeb panels themselves? And so the answer is no. I mentioned it briefly, maybe I didn't say it quite enough. You do want to screed the concrete flush with the top of the GeoWeb cell. That is your form, not only for the space that it's covering, but the depth that it's covering. So you don't want to have additional concrete on top of the panels, because that concrete is going to crack and get washed away. That's because the cells themselves, all of the cell walls, will create mechanical cracks within the concrete, and those would reflect up to any concrete that's over top of the cells. And then because that concrete's not confined within a cell, it's just cracked concrete, and that can always get washed away. If it's concrete that's confined within the cell, if it's within that 3 or maybe 4 inch deep GeoWeb cell, that those mechanical cracks are going to be there. That's going to help give it the flexibility to handle some differential settlement, but it's still going to hold everything in place so that it's still that concrete monolith that you need for your spillway or your dam face. So no, you don't want to have any additional concrete above the GeoWeb cell. So great question. Some questions, can you, when you're driving on the cells on a slope, how does that get held in place? I mentioned really briefly one of the case studies down in Florida. They wanted to be able to drive on the crest and then down the slope onto the pond bottom. And so, yeah, you're driving on that slope. And so that is something that is definitely doable. Typically either a concrete fill or an aggregate fill. You're not really going to want to drive on topsoil too much. Driving on grass is never a great solution, even with the GWIP system. So yeah, that's where you're typically going to be driving on the stone or concrete. But the anchorage that's required to be able to drive on the GWIP panels on a slope is very project dependent. It's going to depend on the type of vehicles, the slope angle, how tall the slope is, all of those sorts of things. And so that's where that project evaluation service, I think, is going to be what is necessary to make sure that we get enough anchorage to hold the panels in place while still supporting those vehicle loads. It could be either the stakes or it could be the tendon system. Again, it is so project dependent. There is no one right answer, but it's definitely possible. So I want to, sort of highlight that, yes, you can drive on steeper slopes with the GWEB panels in place. They can support vehicle loads on, 15, 20, 30 degree slope. You don't have to just be limited to the horizontal crest of your dam structure. So yeah, definitely reach out if you have questions. Let's see some more questions. There was one, is there a difference in the subbase load bearing reduction compared with aggregate or concrete? Yes. So again, I'm getting cliche at this point. There is no one right answer. But yeah, so there is, you can potentially have a difference in your subbase requirements if you choose stone or if you choose concrete infill. Again, it's going to depend on the types of vehicles and the site conditions, what your soil is, what your saturation level is, that sort of thing. Typically, you will have less subbase with concrete. How much less is hard to say, but yeah, there is going to be a difference, and that's something that we can evaluate on a project basis. If you are curious, if you're saying, I think I want to go with a concrete surface, but maybe what does a stone surface look like cross-section thickness wise? That's definitely something we can compare. And again, try and determine what is going to be the most appropriate. Because maybe you have access to cheap stone, but if it's a thicker section, you don't want to do that much excavation, that sort of thing. So yeah, lots of different things to compare, but it's definitely a worthy question. So some questions about the installation. How often do you need the Atra tendon clips? How often do you need stake anchorage or the Atra keys? All of those accessories we talked about. And so it is going to be something that we can help with in terms of how to do the installation. We're going to, through our calculations, determine what all of those spacing and anchorage needs are. Typically, we would say, if you're doing a tendon, you are going to want a single string of tendon all the way from the crest to the toe, tied off to each Atra tendon clip, which is the load transfer device tied to your crest anchorage. If you're doing stakes, maybe you want them 3 foot on center, maybe you want them 6 foot on center, those sorts of things. So we would be able to tell you what is necessary in terms of that anchorage and also how to install it. And we can have someone come on site for that installation assistance. We have, guides and we have videos about installing, but sometimes it is really just helpful to have somebody out there on day one of the install just to make sure everybody is comfortable. And we provide that through ourselves and our distribution network, is that we can have somebody on site to help you with that type of installation. Those installation questions, make sure everybody is happy with it, because you don't need a specific contractor to do it. Anybody can do the installation with the GWEB system. So that is part of the sort of total package that we offer, is that installation assistance. Okay, I've gone over my time. I'm going to answer just one more question in this Q&A, and then please feel free to reach out to me if I didn't get to your question today, and if I don't reach out to you soon about that. So one last question is, how do these systems handle snow removal? So definitely a great question. We're in the upper Midwest. We see lots of snow in Wisconsin and Illinois. We've done projects, all throughout Canada. They see lots of snow there, up into Alaska, northern parts of Europe, all that sort of thing. So yeah, snow removal is definitely a thing to always consider, and they do stand up really well. So whether you have concrete filled, then it's pretty simple. You just plow it off like you would a normal concrete road, no questions there. If it's topsoil, typically you're not going to do snow removal on topsoil. You'll just let it sit in the winter and let it melt in the spring. And then you don't have to worry about the ground being saturated by that snow melt, because it is confined by those GeoWeb cells. So everything is still going to be held in place. The snow can just melt and run off and do whatever it needs to do, all good things. If you do have a aggregate filled system, and maybe it's on an access road and you still need to be able to use that access road in the middle of February, that is unfortunate for whoever has to do that, because it is cold. And I know because I have done it. Northern Wisconsin, out on a dam, there's a lot of wind, it is very cold, but you need to get out there. You got to do those inspections. So in that case, you still can use a snowplow if you want, if that's your normal maintenance method. You can use snow blowers, that sort of thing, anything like that. You can try and put like salts or de-icers down, but you have to be aware that that will leach into your groundwater system. So if you're anywhere near protected waters, or if you're near water that might be used collected for drinking, adding salts and chemicals, maybe not a great solution, but it's an option. So yeah, we do have a number of different methods for how snow removal can happen, and we have those detailed in documents that can be added to bid documents or shared with regulators, anything like that. So it's definitely been considered, and it is doable. It shouldn't be the factor that would stop you from using these types of systems in those sort of cold weather environments. All right. Thank you, everybody who has stayed with me. I have gone over my time, but I hope you all have a wonderful rest of your day. Please feel free to reach out to me if I didn't get to your question, or if you think of something else down the line, or if you have a project that you're curious about. I am more than happy to talk about the GeoWeb system or any of our other products or applications with you. Always interested to see what's out there and happening in the construction world. So I hope you all have a wonderful day, and I will see you in the next one. Bye.